Hello, welcome back to Educator.com and welcome back to physical chemistry. So today we're going to take a little bit of a detour from the quantum mechanics and we're going to talk about complex numbers. So let's get started. Okay, so complex numbers, we represent the square root of -1 with an I. So I squared is equal to -1. Now complex numbers are represented this way. We usually use the letter Z for a complex number, and it's something like A plus BI. So A, that is the real part of the complex number Z, and B we call the imaginary part of the complex number Z. So again, Z is the standard variable, just like X for real numbers. We use Z for complex numbers. Now, geometrically, the complex numbers are represented in the two-dimensional plane. So geometrically, we represent complex numbers in R2, well, I won't say R2, I'll just say the two-dimensional plane. In the two-dimensional plane called the complex plane. So we have something like this. There we go. So this is the real axis, the real number line that you're used to, and here we just call it the imaginary axis. So again, this is just a pictorial way of actually representing a complex number. So if we have some complex number like this, actually we have, let's mark off a couple of points here. 1, this is -1, and on the imaginary axis, this becomes positive I, and this becomes negative I. So if I have some complex number like that, okay, this is going to be the B, this height, and then this part right here, that's going to be the A. That's it. Nice and simple. Okay, let's talk about some operations with the complex numbers. So our operations, you can add, subtract, multiply, and divide complex numbers the way you do any others. So let's talk about addition first. And I think it's best to just represent it as with an example here. So addition, if I have 2 plus 3i plus, let's say, 7 minus 4i. So what you're going to do is you're going to add the real part with the real part, and you're going to add the imaginary part with the imaginary part. So it ends up being 2 plus the 7 is 9, 3 minus 4 is going to be minus 1i. There you go. 9 minus I. Nice and simple. Okay. So let's talk about subtraction. It's the same exact thing. You're just going to be changing some signs. So subtraction, let's do the same thing. Let's do 2 plus 3i. This time we'll subtract 7 minus 4i. And once again, you're just going to go 2 minus 7. So you have minus 5. And you have 3i minus a minus 4i. So you get plus 7i. That's it. Nothing very strange about it. Multiplication, also very straightforward. You're just going to multiplication. Let's see. For multiplication, you're just going to treat it like you would any other binomial. So we have 2 plus 3i, and we have 7 minus 4i. So we're going to do this with this, the inside, the outside, that same thing. Or if you want this with this, and then this with this. How you do it actually does not matter. So 2 times 7, we have 14. And then we have, I'll just do the inside. We have plus 21i. We have minus 8i. And here we have, this is minus. 3 times 4 is 12. I times I is I squared. And since I squared is -1, this becomes 14. 21i minus 8i, this becomes 13i. And I hope you're checking my arithmetic. I am notorious for being bad at arithmetic. And this becomes a plus 12. So this becomes 26 plus 13i. There you go. That's it. Just multiply it out. Okay, now before I do division, I want to introduce the notion of the complex conjugate. Well, if a plus bi is a complex number, then I'll say its complex conjugate, which is denoted as z with a little asterisk on it, z star is equal to a minus bi. Basically, all you're doing is switching the plus to a minus. So geometrically, it looks something like this. If this is the complex number, its conjugate is just a reflection along the x-axis. A plus bi, a minus bi. That's all it is. Okay, so let's go ahead and do a division here.